Hi everybody who is watching this video. I would like to welcome you into this fantastic moment of the YouTube channel on the YouTube channel called Tanzania Online A-Level Secondary School. Tanzania Online A-Level Secondary Schools, Olenjolai in square bracket. It's a little bit fantastic and serious channel for the serious students, which will be using different tips and different tricks and different techniques and different aids on teaching advanced concepts. Actually, that advanced concepts are a little bit complex for advanced chemistry, even in advanced physics or in advanced mathematics, but I will be trying my level best to simplify or to break down the concept that you are going to learn into the simplest form. So stay tuned on this channel, and I would like to welcome you onto today's lecture, or this is video in series that it's lecture or session or period 11. So it means that I've already taught 10 lectures already, or 10 sessions, or 10 periods. So make sure that you go through the previous session, and especially that the sessions or the lecture teach you a lot or in details about the hydrogen spectrum, because that's the fundamental concept that we need in order to understand today's concept called the quantum number at the one of the concept of the atomic structure. So the departments where you are is called advanced chemistry, and the subject advanced chemistry. The main topic is called general chemistry for A-level and for the United Republic of Tanzania. And the atomic structure, that's the topic that we'll be learning in this class. This material will be for the pre-form 5, for the form 5, for the audience level 5 or level 4 or level 6 who are doing the diploma students, and also for the form 6 who are getting prepared for the final exam. In case that you want to offer the Thanksgiving offering, this the valid phone number or mobile number, or in case that you want to use a bank transaction, make sure that also you watch the descriptions of this video. Below the video there you'll see the descriptions. You have to click the point where that show more, and then you'll see all the details concerning about what you're enjoying on this. My name is Olenjolai from the beautiful country United Republic of Tanzania. Let us join together on this interesting, fantastic, beautiful, and a unique concept in atomic structure that called the quantum number. It's a little bit confusing, many students, but I'll try my level best, and I'm praying to God to help me to deliver this concept in the simplest way, and also for you to understand and make sure that you keep this stuff until the time that you will be asked to use them. Okay? So the concept that you are going to learn today is called quantum number. Just to do the quick review, the general quick review, because actual that the quick review of the previous lecture, we have been discussing about the mass spectrometer. If you do remember, it's a mass spectrometer, very important device in chemistry lab. Also, I have taught you about the mass spectrum. So when you say the mass spectrum, especially on computing relative atomic mass. Next, I taught you about we call it the hydrogen spectrum, right? Hydrogen spectrum. So in hydrogen spectrum, we learn that the hydrogen shells containing a number or several energy levels, right? Energy levels. So that's what I taught you, and we give them names. So this is one shell. It means the shell of hydrogen spectrum. Then the next concept, we have been spending much time on atomic theories. Atomic theories, where we form Rutherford, J.J. Thomson, Rutherford, Fonty Dalton, Fonty Bose, Hansen, Beji, Broglie, and Schrodinger's, and so forth. So that's what we have been discussing. So today, I would like to introduce you this concept of the quantum number. It's a little bit long. It has four sub-concepts, which you have to understand them. But the goodness is actually explaining the atomic structure in detail. This does not need something else or the prerequisite material of all level. This is the new concept at all that we are teaching the A-level students. So the fundamental question that always I used to insist you when you're learning something new, the first question is what is the meaning or what is quantum number? So the word quantum, I taught you about quantum theory, but today I want to teach you about quantum number. So say quantum number. Okay, say quantum number. Quantum number. Write in your brain, please. What is quantum number? Or in some of the books, they can ask you that. What are quantum? So in plural, quantum numbers. So what are quantum numbers? What do they mean, quantum numbers? So that's the question that we have. Okay? You can find different ways of defining, but I would like to share with you one way we can define. Quantum numbers are the set of numbers. So these are the set of numbers. Used to describe the position and the energy of the electron, of an electron in an atom. Some of the references also define that quantum number, that are the numbers that describe the properties, or describe all what is to be known about electrons. Describe properties of 40, or no, not a property, it's a structure. The structure of the atom. The structure of the atom. The structure of the atom in regard to the allowed energy, right? And then also this concept, the quantum number, will describe the shape of the orbital. It will tell you about the shape of the orbital, as I will be teaching you step by step, and also direction of the spin, of electrons. It's a heavy definition, intensive definitions of quantum number, but don't worry, I'll be breaking down. So quantum numbers are a set of numbers. So these are the set of numbers used to describe the position of 40, the position and the energy of an electron in the atom. Or we say that these are the numbers that describe what? Describe the structure of the atom in regards to the what? Allowable energy, shape of the orbital, and directions of the spin of electrons in the atom. So that's the meanings of quantum numbers. So these are very important numbers in chemistry. Okay. So then we say that in if you know now the definitions of quantum number, I would like to take you to the next fundamental part, which we call types of types of quantum number. How many types of quantum number do we have? Types of quantum numbers. Types of quantum numbers. So we say that there are four types. There are four types of quantum number. There are four types of quantum number that are the first type, we call it a principal quantum number. Say with me, principal quantum number. Principal quantum number. That's the first type, and this will be having notation of n. The second type, we call it subsidiary, or we call it just different names, subsidiary, angular, or secondary, or orbital quantum number. So subsidiary, 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 subsidiary quantum number, subsidiary quantum number, and this is L. Then the third type of quantum number, we call it in chemistry magnetic quantum number. Magnetic quantum number. Magnetic quantum number, and this we use the letter M as notation. And the fourth type we call it spin quantum number. Spin quantum number. Okay, spin quantum number. So this spin quantum number, we use this notation plus or minus half. So we have four types of the quantum number. So in case that we are the chemists or the students who love chemistry, we have to learn those four quantum numbers in order for us to understand the concepts of what? Of quantum number. So let me teach you, I'll be teaching you in lecture 11, lecture 12, hopefully even lecture 13, all of those are quantum numbers because they are very important. This is very important part where the question for the pre-national, for the MOCO, for the next exam, midterms used to be asked. So the first type, we call it principal. Okay, so we call it principal. So wait, say with me, principal quantum number. Say it. Principal quantum number. Again, principal quantum number. Principal quantum number. Principal quantum number. In notation in chemistry, we use the lowercase n. So the fundamental question that I told you that you have to ask yourself when you are learning something new, what is principal quantum number? What does it mean, principal quantum number? What the meaning of this term, of this vocabulary, quantum number? So what is principal quantum number? So I found one definition for you. Principal quantum number is the main, so this is main, right? Is the main energy level. So this is main energy level, right? This is the main energy level in which the electron is placed. So we place electrons in the principal quantum number. So the principal quantum number, we say that is the main energy level. So this is the main energy level found in the atomic structure in which electron is placed. So principal means main. So the lecture is about quantum number. Okay. Who proposed the principal quantum number? That's the question. Who proposed, or who discovered, who explained, who proposed the principal quantum number? Right? Principal quantum number. So according to the chemistry literature, we say that this concept has been proposed, so it has been proposed by the chemist, proposed by the chemist, by the chemists, by the Bohr. Okay, when did he propose it? When he was explaining. So when he was explaining, when he was explaining, when he was explaining the hydrogen spectrum. Hydrogen spectrum. So that the times when he's introduced or proposed about this principal quantum number. So again, we say that the principal quantum number, principal quantum number is also known as primary. So this is also known as primary quantum number. Primary quantum number. Primary quantum number. So that the other name. So we can call it principal quantum number, or you can call it primary quantum number. Then again, another concept that you have to know, or we have to learn, you know that we want to make these things, or the chemists wanted to make these things global. This concept is worldwide. So then they've discussed about notation. So the next part now, I want to teach you notation of primary quantum number. Primary or principal quantum number. Notations of primary quantum number. Quantum number. So I say that the principle, I'm using these two names interchangeably. So for you to be familiar, the principal quantum number is notated by lowercase m. By m. So by the lowercase m. So this is the notation. So whenever you see m, it means that this is principal quantum number. And in Bohr, so in hydrogen spectrum, we use that the energy level. So again, we say that also the principal quantum number, principal quantum number is denoted by whole numbers. So you have two letters, whole numbers. So we have two whole numbers. And when you say whole numbers is that to say that it will be 1, 2, 3, 4, etc. So these are the whole numbers. So n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Also, we can notate this one by letters, written in capital letters. Okay, capital letters, which are there's 4 capital letters that has been chosen. Okay, capital letters, and these are K. So this is K, this is L, and then the other capital letter is M, and also we have N. So those are the capital letters, and these capital letters have close relationship with the whole numbers. We call them the whole integers. Have close relationship with the whole number K, L, M, N. Those are consecutive letters in alphabetical order. So they have close relationship with the whole numbers. So for example, K stands for energy level, n is equal to 1. So instead of calling that where principal quantum n is equal to 1, we can call it K. Right? And then L stands for energy level is equal to 2. Very important notation. M stands for energy level is equal to 3. N stands for energy level is equal to 4. So the letters K, L, M, and N and numbers 1, 2, 3, and 4 are used interchangeably to denote principal quantum numbers. So we say that these letters K, L, M, and N, K, L, M, N, and the whole numbers 1, 2, 3, 4 are used interchangeably. Then the next question you might ask yourself, can we present principal quantum numbers by using negative integers? No. That's not acceptable. We only accept the positive integers from 1 to infinity. So it says theoretically say that the principal quantum number takes values, principal quantum number takes any positive integer, and a positive integer from 1 to infinity. When you say infinity, this is infinity. So it means that you'll find n is equal to 1, n is equal to 2, n is equal to 4, n is equal to 8, possibly, if it's there, n is equal, for example, 10 or 8, then you go to n is equal to infinity. You will never find the principal quantum number is equal to -1. You never find the principal quantum number is equal to -4. You never find the principal quantum number is equal to -3. You never find that. Okay, so bear that in your mind. Okay, so according to this fundamental concept, you will find that, or you have found that in previous lecture you'll be learning about this principal quantum number. Because n is not something new. You do remember that in both I told you how to derive the formula to compute the NH in the energy level, which is equal to -13.6 electron volt over n squared. So what is n? The n we'll be discussing is this is principal quantum number. Also in Riebeck equations we have Riebeck constant, open bracket, 1 over energy, lower energy level square minus 1 over higher energy level square. So that's all about the principal quantum number. That's what we'll be discussing. So why do we need this principal quantum number? What informations can be deduced from the principal quantum number? So application of what is principal quantum number. Applications of principal quantum number. Applications of principal quantum number. So the question is, what are the applications? What are the applications of principal quantum number? What are the applications of principal quantum number? So there are many applications of principal quantum number in chemistry. I found 3. I'll be teaching you 3. Then you can find more than that. The first applications of principal quantum number is used to specify probable distance of electrons from the nucleus. So to specify the probable distance from of an electron means that orbital from the nucleus, electrons from the nucleus of an atom. So the principal quantum number is used to specify the probable distance, because we say that according to the de Broglie, or according to the Hensen-Bates, we have